And what's up, ladies and gentlemen? It's Mr. Simkins in the Simkins Physics Closet. I'm in a closet here today, broadcasting to you live. Welcome to Lesson 1, Zoom Day 1, Launch Day 1. It is the Science Toolkit. So if you missed the live stream, check out this lesson. Here's what we're going to cover in the entire first unit. We call it Unit 0. We call it the Science Toolkit because before we just jump right into physics and learn all these equations and formulas and how to use them, we got to know the basics of how to do science. And so these are the things we're going to cover in our first unit. Today, our first week, or I guess we could say our week 2, because we met for the 2 days last week. Our goals this week are to cover the scientific method, percent error and averages, precision and accuracy, and then we're going to conduct and design experiments as well. So that's, if you look at our whole unit overview, the things highlighted in orange are the things that we're going to look at this week. So to launch into today, I'm going to teach you 2 skills. The first skill is percent error, what that means, how to calculate it. The second skill is averages. What does that look like as far as the math goes, and how do we leverage that to do analysis of data? The new terms we're going to talk about today are precision and accuracy, and we're also going to talk about data that can be quantitative or qualitative. All right, rock and roll, let's do it. So what can we do with data? Well, let's take a look at a sample. Some students are finding the melting point of alien titanium. I don't know, something fun. And we see we have 3 students. We have student A, student B, and student C. These 3 students are taking some data, and they did 3 trials. Now, first thing I want to mention is whenever you conduct an experiment, you should be doing multiple trials. You see, the scientific method tells us that we need to be meticulous, but it also says that experiment should be repeatable. Well, why not repeat the experiment in itself? Why not do multiple trials? That's how we ensure that our data is higher quality. So that's the first thing I just want to drop in there for you. But in order to figure out, hey, if I take 3 different values, what's the big picture for what those values mean? Well, we're going to calculate the average of 3 values. So, for example, if I take student A and there's 3 measurements, all you have to do to calculate the average is take the number of measurements that you have. We'll call that n, and then you got to add up all the individual measurements up at the top. All right. So in this case, we're going to add measurement number 1 plus measurement number 2 plus measurement number 3 and divide by 3. So don't be confused with that n. It's not something fancy. It just stands for the number of trials or the number of data points you have. And so this might look a little something like this. You do 183.5 plus 185.9 plus 184.6. You divide it by 3, and whatever answer you get is going to be your average. So this is not new. You guys already have known this since probably elementary school. To take the average of a set of numbers, you add all the numbers up, you divide by how many numbers there are. So in this case, our average, if you do it in your calculator, it would be 184.7. All right, we could do the same process. We could add these 3 numbers together, divide that number by 3, you get 186.8. We could add these 3 numbers together, divide by 3, you get 181.6. Take a moment now to pause this video if you're watching asynchronous. Pause this video and try out those calculations. Make sure it comes out correctly in your calculator. If you're not sure what to use and you're on your laptop, you can hit the Windows button and type in VTI. That stands for Virtual TI-83, and it will actually pull up, everybody has this on their laptop, it'll pull up a virtual calculator for you. So if you're saying, well, I don't have a calculator to use, yes, you do. It's right in your laptop. Again, that's hit the Windows key. That's the little one with the 4 things. It's between the Control and the Alt button on the left side of the bottom of your keyboard. Click that, start typing VTI, and if you type in VTI, you can find the VTI-83. That'll pull up the virtual calculator for you there. So go ahead and take a moment, pause this video, and make sure you get the same answers out of your calculator that it has here. Okay. So we talked about the average, taking the average of our values. How do we know if our data is any good? Well, in some cases, if there is a known quantity, like the acceleration due to gravity, for example, is known to be 9.81 meters per second squared. If we're shooting to verify a value that's already known, we call that the accepted value, right? And so if we look at these 3 students, which one of them had an average measurement that was closest to the accepted value? Well, student C was in the 181s. They were pretty far off from 185, right? You notice that student B and A are getting closer, but student A is only 0.3 away. So in other words, if you take the difference between 185, if we do 185 minus 184.7, we figure out how far away from each other they are. They're only 0.3 apart from each other, degrees Celsius in this case, right? So student A, we would say, has the most accurate data because student A's average is closer to the accepted. And if you are an English person, you'll appreciate the alliteration that just took place. To gauge your accuracy, you compare your average to the accepted. And whichever average value is closest to the accepted value, in this case the accepted value is defined as 185, that's going to be the one that says is the most accurate. What about precise? So we're going to differentiate between accuracy and precision. Accuracy is like I hit the mark, I got close to the answer I was supposed to get. Precision is a different type of thing. It tells us about, are my measurements close to each other? And so if we look at student A and B and C here, and I'm just going to go back here and kind of clean up the slide for you real quick so the red isn't distracting you. So let's do that. Can I just erase everything? Can I say blow it all up? There we go. Boom. If we look at these students' data, the way that you figure out precision is you can do a little math. And I'll show you that here in just a second. So let's first talk about how we can evaluate accuracy. All right. We can do this with something called percent error. Oh, that's one of our goals for today, percent error. We can actually calculate the percentage difference between the value that we got and the value that we were supposed to get. This is called percent error. So the percent error formula, that's an eraser still, let me change to a pen. The percent error formula looks like this. Percent error is calculated by taking your accepted value. All right, so in this case it'd be 185 minus the experimental value. Now that's the average value that you get after doing the experiment. Oh, that makes sense. The experimental value is the one I get after doing the experiment, 184.7. I'm going to divide that by, again, the accepted value, so back to 185. Now you might notice there's these two vertical bars right here and here. If you're good with the math, you know what that means. Do you know what that means? Absolute value. That's right. And absolute value means you always get a positive answer. So let's say the accepted value were smaller than the experimental value. In this case, it's not. But if it were and you got a negative answer up top, you just make it positive. All right. Then the final thing you do to get it as a percentage is you're going to multiply that answer by 100, and that's going to get you a percentage. So 0% means you're right on the money. You have 0% difference between your answer and the accepted result. If you have 10%, you're still pretty close. You're about 10% off. That's not too bad. 20% starts to push it. You're getting pretty far off. Maybe you did something incorrectly during the procedure of the lab. 30%, 40%, whoa, we're like, all right, we got to go back and seriously reevaluate something because we really messed up something. All right, so percent error just gives you a feel. The lower the percent, the higher quality your data. And so if I asked you here, hey, which of these students has the most accurate data, you could calculate the percent error for each one. Whichever has the lowest percent error has the best quality data because you're closest to the real answer. All right, so we could do that quantitatively. If you carry out those calculations, I'll just do a quick example for you, and then I would like you guys to try the other two. So I'm going to do it for student A. So if I follow this formula right here, okay, if I follow that formula, it's going to be it's going to be accepted value, which is 185, minus the experimental value, which is 184.7. Absolute value on the top, divided by the accepted value, so that's 185, and then it's going to be times 100. And I'm going to pause the video here for a second and pop the answer up. Go ahead and put it into your calculator, hit pause, and then check back in when you have your answer. All right, if you take a look at my calculator, you can see the math I did. I took the difference of the accepted value and the experimental value. I divided it by the accepted value, and then this number, the last step here is to multiply that by 100. So I'm going to say multiply by 100. That puts it as a percentage, and our percentage that we get is 0.162%. 0.162%. Is that really close to zero? Yes. What does that mean? That means our data is quantitatively very accurate. Why? Because the lower the percent error, the closer you are to the real answer. So take a moment, pause the video, and calculate the percent error for these, and calculate the percent error for these, and then check back. All right. Let's take a look at precision. Oh, you're dying to know the answers. Hold on, let me put them up here for you. All right, and since I know you're on the edge of your seat, if we look at student A, their percent error for this experiment was 0.162%. Remember, the lower the better. Student B's percent error was 0.97%, and student C's percent error was 1.84%. So earlier we had the intuition, we had the gut instinct that student C had the least accurate data because they were farthest from the real answer, and the percent error shows us quantitatively. By the way, I forgot to define that. Quantitatively means like a quantity, like a number. So if I say I'm evaluating it quantitatively, I'm going to say I'm putting a number to this. So this is how you put a number to how accurate was my data. You do that with percent error. All right, let's look at precision quantitatively. That means we got to put a number to precision. All right, precision tells us if our values are close to one another. And so one easy way to do this isn't an exact science thing, but one easy way to do is just look at your largest and your smallest values and take the difference between them. So for example, student A, when we're talking about precision, we're saying, are they all close to each other? right? And so that's why we take the difference between the two, the highest and the lowest number. So you see how I took the highest number, 185.9, and I'm going to subtract 183.5. All right, that's going to get me how much of a spread there is, basically, how much difference is there between this set of numbers. We can do the same for student B and student C, and if we do that, we see the following. Now, quantitatively means a number, a quantity, so which student has the highest precision quantitatively? Student C. Why? Because the numbers are closest together. They have the smallest difference between the highest and lowest range. And if you look at these numbers, look how close they all are. They're all in within between 182 and 181 point something. So they're all very close to one another. And so that's how you evaluate precision. So accuracy is, did I get close to the right answer, the accepted value? Precision is, how close is my data clustered together? Your values are close to one another. That's how you would evaluate those quantitatively. Let's talk about the word qualitatively. Well, qualitatively sounds like the word quality. And if I describe someone's quality, then I am making a description. So there's not a number, it's like a description of something. And so when we talk about qualitative observations, we're just talking about the observations that we're making. It could be color, it could be size, it could be shape, those sorts of things. So let's look at accuracy, all right? If we look at it qualitatively, remember, accuracy means, are we close to the right answer? Well, which one is closest to the right answer? Okay, well, if we take these bullseyes, let's say we're at the range shooting some arrows or something, we take these bullseyes and we say which of these sets of shots it represents a high accuracy. Well, we're going to be looking at which one met the mark. So which one meets the mark? Well, we see this third target right here has lots of shots that meet the mark. And so we would say those are accurate. But if we recall correctly, accuracy means on average was your answer close to the right one. And so obviously all these shots clustered up here are not accurate. They're not close to the bullseye. They don't hit the target. And these guys are kind of all over the place. But where it gets a little tricky is this one. What do you think? Is that one accurate or not? Well, what if I took the average of all those points? Where would I land? Like spatially? Probably right about here. And so that one's a little confusing, but that one actually is accurate. All right, let's talk about precision qualitatively. What qualities would indicate a high precision? Well, high precision means your values are close to one another. They're kind of clustered together. And so you can see this visually very easily to describe it qualitatively. You look up here and you see that that is a precise instrument, whatever I happen to be making those arrow shots with. And you'd see the same case right here where all of those are grouped together. So that's accuracy, precision, and we worked average and percent error into there. So to wrap this up, what I'd like you guys to do is try it. If you learn something new, then what you got to do next is just try it out and see how it goes. So this is on your packet that you can download. If you want to open up Microsoft Word and use the draw tool to draw your work in there, you can show work, you can write it on some paper and take a picture and submit it, whatever you're most comfortable with doing. But what I'd like you to do is take these values from these two students, we see student Z and student X, all right, and what I would like you guys to do are those three tasks right there. First, calculate the average. That means we're evaluating the average quantitatively. We're getting a number for the average there. Then I would like you to calculate the percent error. All right, so you would use the formula for accepted minus experimental over accepted times 100, taking the absolute value of the top, calculate the percent error for each student. With that number, you can quantitatively evaluate the precision, or sorry, the accuracy. How close were we to the right answer? So doing the percent error will help you quantitatively evaluate the accuracy. The lower the percent error, the higher the accuracy. Finally, the last one, number 3, answer the two questions. And when I say the two questions, I mean these right here. So I would like you to say which student is most accurate and which student's data is most precise. And here's the important thing that you have to get used to for this year. Justify, all right? Mr. Simkins cares about your feelings. Physics does not. Physics cares about the argumentation, the logic, the facts behind the matter. And we need to make arguments in science class according to data. And so what I want you guys to do is justify your answer to these responses. Once you are done with your calculations, both for average and percent error, once you have answered which student is most accurate and which is most precise, and you have completed that Word document, that's going to be on page 3 of your download, I want you to go to File, Print it as a PDF, and only print page 3. I'll include a short video with directions on how to do this. And then you're going to submit that to our assignment for this launch day, which you can find located at the top of the module for this week. All right, so that's our little overview of the first things that I want you to know as far as science goes. For the rest of the week, we're going to unpack the scientific method. We're going to go outside and collect some data. We're going to talk about designing a good experiment. And we're going to wrap up the week with a big overview of how all of this ties together. So until next time, I'm Mr. Simkins in the Simkins Physics Corner.